We're talking specifically about right triangles today and similar right triangles. So this first theorem, we need to remember before we kind of talk about what it says, we need to remember the different sides of a right triangle. So remember that across from the right angle, that side is called the hypotenuse. The other two sides are called the legs. Okay, so you've got to be able to pick that out. All of these pictures today for the examples are going to be right triangles, but notice how they've drawn a piece in the middle. So you're going to see that on every example. Here's how they draw that. They go from the right angle and they drop a side straight down so it's perpendicular to the hypotenuse. And you might see them like tell you how long that is, or maybe they'll call it X and you have to find how long that is. You need to note that that piece in the middle is called an altitude. Okay, you're going to see that, like I said, on every example. That altitude is going to be drawn in the middle there. Now, let's say that they did draw that in there and called it X, and maybe they told you that from here to here on the hypotenuse is 4, and from here to here is 16. And they might say, use similar triangles to solve this for X. When they draw the altitude in, they've created 3 similar triangles, which kind of makes this a pretty intense scenario here. There's the small triangle, the medium triangle, and the whole thing is the big triangle. And they're all similar because of angle. They've got a 90 and they share an angle. So like if I redrew all of these, the small one is kind of flipped on its side. It's right here. So if I flipped it so all my triangles are going in the same direction, the small one, this leg is 4 and the bottom leg is X. The medium one is sitting in the position I want it to be, so it's right here. So here's what it looks like. X is this vertical leg and 16 is the other one. The entire thing is, I'm going to flip it around, and here's what I know about the whole triangle. I don't have either of the legs, but I can see that the hypotenuse, if I added these two pieces together, it would be 20 long. Okay, so this one picture, that one altitude drawing in, it's created 3 similar triangles. So if you redrew all of them, you could use these first 2 to set up a proportion. I could do something like 4 over X equals X over 16. Wouldn't even need to use the big triangle. Okay, so if I cross multiply and divide there, I get X times X is X squared equals 64. If I square root both sides, I would get X is 8. I don't know about you, but that is kind of a lot of work in my opinion. I don't want to redraw 3 different triangles for each example here. That's a lot, especially when they're flipped around, and that's hard for me to look at. So these next few things that we're going to write in, these are all shortcuts to avoiding having to redraw 3 triangles. Okay, so these are good things. This first thing, and we need to know this for these 2 what are called corollaries down at the bottom, and we need to know what a geometric mean is. Realize, you guys, and I'm going to make a little note, in algebra, the mean is when you like add 2 numbers together, we'll call them A and B. When you add 2 numbers together and divide by like how many there are, so maybe 2, that would give you, we'll call it X, the mean. Okay, average is another word. If you add the numbers together and divide by how many there are, that means the average. In geometry, finding the average of 2 numbers is a little different than that. Okay, so let's write this in. If something says find the geometric mean, here's what they want you to do. The geometric mean, so I'm going to call it X, of 2 numbers and we're going to call those A and B, is when you have this scenario going on with a proportion. So the geometric mean, we'll call that X. It's the number that you can put on one diagonal in a proportion that makes this whole thing true. So the two numbers you're trying to find the geometric mean of, A and B, those go on the other diagonal. And let me give you an example. Squeeze this in here. If they say geometric mean of maybe 2 and 18, you would set up a proportion, and you want to know what's the geometric mean, so you put X and X, that's what I'm trying to solve for. You'd put the numbers that they gave you, 2 and 18, on the other diagonal. If you solve that proportion, you have the geometric mean. So you would do x times x is x squared equals 36, and then you'd square root it, and you would get 6. And honestly, you guys, it's exactly what we did right here. Okay? So that's what they mean if they say find the geometric mean. Okay, you're going to set up a proportion. Now, both of these corollaries, and if you remember this word, corollary just means shortcut. So these corollaries are shortcuts, like I said, to avoiding having to redraw all three triangles. So the first corollary, it deals with finding like an altitude, a piece on the hypotenuse. We're going back to this original picture. Now, I'm just going to write it as a proportion because I don't like writing all these sentences. It doesn't make sense to me when I do that. So here's a shortcut for setting up the proportion that we got on the first example here. If you have a proportion here and you're talking about the altitude, the piece in the middle, the shortcut says the altitude is the geometric mean. So it's the number that you put on this one diagonal here, like I did up here. It's the geometric mean of the two pieces on the hypotenuse. So the numbers that you would put on the other diagonal are the two numbers on the hypotenuse. So I'm going to write piece number 1 on the hypotenuse. And down here, I'm going to write piece number 2 on the hypotenuse. Okay, so it's kind of a shortcut proportion, and I'm telling you right now, this stuff takes practice. It is a little intense, a little crazy looking at first, but here's how I would use this corollary to kind of have a shortcut going on for the initial problem that we did. I didn't have to redraw any of this. I could have just looked here and said, oh, x is the altitude, so it should go on this one diagonal in both spots. And the numbers I should put on the other side should be piece number 1 on the hypotenuse and piece number 2 on the hypotenuse. We determined from the very beginning that this was the hypotenuse of the main triangle, and here are the two pieces, 4 and 16. So those are the numbers I should have put on either diagonal. And if you notice, that's exactly what I ended up doing. I just had to do a lot more work to get there. Okay, so these corollaries are good for you. Okay, they're shortcuts. They make your life easier. The second corollary is another shortcut to redrawing. So this one deals with the leg of the triangle. So maybe they tell you, and let's see, they'll draw the altitude in. So get that in there. Maybe they don't say anything about the altitude. Maybe they say, hey, find x, and x is one of the legs of the triangle. And maybe they give you the two pieces on the hypotenuse as 4 and 5. Okay, so here's what this shortcut says, and it's another proportion. It says that the leg of the triangle is the geometric mean. So it's the number that you put on this diagonal instead of the altitude. So whatever the leg is, you're going to put it here and here. On the other diagonal, you're going to put the piece on the hypotenuse that the leg touches. So I'm going to say piece on the hypotenuse that it touches. On the other bottom right side, the other part of the diagonal, that is the length of the whole hypotenuse. So here's how I would use that shortcut to solve this problem right here. The leg, which is x here, leg, hypotenuse. The leg, I'm going to put that on one diagonal, x and x. The piece on the hypotenuse it touches, so again, you guys, here's the hypotenuse. The piece that x touches of that is the 4. And the length of the entire hypotenuse is 4 plus 5, which is 9. I don't know about you, but that's a whole lot less work than redrawing all 3 triangles. Once I've got it set up, I just cross multiply. So that's going to give me x squared equals 36. And then I square root, and I get 6 for the leg. Okay. Flip it over. And we're going to show you a few examples of kind of how to use this when they ask you for more than one piece. So you're going to have to get used to these shortcuts and what they're saying. To find y, that's the altitude. So I need to use the first corollary with the altitude thing. Okay, so the altitude is the geometric mean. So I put y here and here. Maybe we should go in and label the sides on the triangle. It should be very obvious the piece in the middle is the altitude. Across from the 90, this is the hypotenuse. That makes this side a leg and this side a leg. Okay, so the altitude is the geometric mean of the 2 pieces on the hypotenuse. So 2 pieces on the hypotenuse are 5 and 5. Once it's set up, hopefully it's easy. You just cross multiply and get y squared equals 25. Square root both numbers, and you get y is 5. Now to get x, x is one of the legs, so I want to use this the second corollary that involves the leg. The leg goes on one diagonal, then it's the piece it touches and the whole hypotenuse. Okay, so the leg is x. That goes on one diagonal. The piece on the hypotenuse it touches is 5. The length of the entire hypotenuse is 5 plus 5, which is 10. Okay, so cross multiply, and I get x squared equals 50. Square root. And, ooh, notice the directions say you want to leave it in simplest radical. That means no decimals. You got to use factor trees. So maybe I do 25 and 2, and then break this down to 5 and 5. So x would be, let's see, for every pair, you bring 1 out. So 5 comes out, 2 stays under. Okay, next one. Same thing. Maybe let's pinpoint, let's see, across from the right angle, this is the hypotenuse. So 10 is a leg and y is a leg. They didn't even label the altitude, so you will not use the first corollary. It involves the altitude. If they don't give that to you, you don't use it. We're only using the leg shortcut. Okay, let's use, we have to use the 10 leg first, because if we use y, we're going to have y and x in there, and we can never solve that. So 10 is the leg, which is the geometric mean, so you put that on one diagonal. The other 2 numbers, it's the piece it touches on the hypotenuse, which is 5, and the whole hypotenuse, which I'm going to have to say is x plus 5. Okay, so cross multiply. Don't forget you have to distribute the 5 when you do your cross multiplication. So that's 5x plus 25 equals 100. Subtract your 25 and divide by 5, and you get 15. Okay, to find y, and maybe I'll come in here and label x as 15. Y is another leg, so I'm going to use that same corollary and put y as the leg on that one diagonal. It's the geometric mean of the piece it touches, which is 15 this time. And now we know the whole hypotenuse is 15 plus 5, which is 20. Okay, so cross multiply, and you get y squared equals 300. Square root that, and you're going to have to use your trees again. So I could do like 103. Maybe I could break that down to 10 and 10. And then 2 sets of 5 and 2. Okay, so to rewrite this, a 5 and a 2 would come out, and you'd multiply them to get 10. 3 would stay underneath, and you'd write 10 radical 3. Okay. On example 3, you've got both corollaries being used this time, and maybe I'll label again. This is the hypotenuse across from the original 90. Notice if the whole thing is 6 and this is 4, then I know this little piece is 2, which I'll probably need to know. Here's a leg, and I'm using the altitude this time. Let's go ahead and find x first. That's my altitude shortcut. So the altitude goes on one diagonal, and the altitude is x. On the other diagonal, it's the two pieces on the hypotenuse, which is 4 and 2. Okay, cross multiply, and I get x squared equals 8. Square root, and you'll have to do factor trees. You should get 2 radical 2. To find y, that's the leg this time, and the leg is the geometric mean of the piece it touches, which is this 2, and the whole hypotenuse, which is 6. Okay, cross multiply, y squared equals 12, square root, factor trees, and you should end up getting 2 radical 3. We're going to skip this last example and just try some more next time.